Hi, my name's Gary and welcome to the channel. The video you're about to watch is one that I moved from my old YouTube channel onto its new permanent home on this YouTube channel. If you have any questions about the content that you're about to watch, go ahead and put it down in the comments below. If you're new here, hit that subscribe button, and if you like the content, go ahead and give this video a thumbs up. Both of those things really help support the channel and give me the ability to continue to produce more content for you. So without further ado, on to the video.
Alright guys, welcome back for video 3 of 3. I just wanted to explain my setup a little bit here at the power panel side. So what I essentially have set up here is power feeding my inverter. My inverter then has its own automatic transfer switch in it that switches between batteries and utility. So that output is then fed into this setup over here. And then this setup interrupts each one of these individual breakers that I've chosen. Not all of them. It's only set up for to interrupt 6 breakers. So I interrupt 6 specific breakers that I have picked out that are things that I basically need to run, which to be honest with you covers most of the stuff in my house, from lights to TVs to just garage door openers, different things that I have identified as critical circuits that I would need in the event of a power outage. So just to kind of walk through the system a little bit here, I'm going to give a really high-level overview on how the system actually works and how the power flow goes, because there's been a ton of questions on, you know, how's the power getting in the system. I don't really understand, simply because you have all the wires going through, you know, all the conduit, and it's kind of hard to understand the flow of things. So I'll try to give my high-level explanation on how this works. So there is 2 feeds of power that come in, A and B side, that come in and feed these circuits. So what I've essentially done here is I've added a 30 amp breaker in the bottom here. And you can see that it's labeled garage inverter, because my inverter is currently in the garage. So power comes in from the utility. It feeds this breaker. This breaker then runs into this junction box, runs through this tube, up the wall, and out into the garage, and it feeds utility power into my inverter. My inverter then has a automatic transfer switch in it that will switch between utility power and battery power. So it runs on utility power all the time until it doesn't detect utility power, and then it switches over to outputting battery power from the batteries. So the output from the inverter then runs down this wall. It comes into this box, is just a junction box, and then it goes into this circuit breaker. The circuit breaker is just to protect the inverter in the event that something gets backfed from, you know, one of the circuits in the house or something like that. Once we come out of this box, it feeds all these switches. So it's protected by this breaker to make sure we're not pulling more than the 30 amps that I'm allocating for all these circuits. And then each one of these has its own individual breaker. The red ones are 20 amp, the black ones are 15 amp. And I'm currently have 6 different circuits inside my house interrupted. Now, the thing about this box, which I think this box is just, you know, one of the best things for this kind of setup, as you can see right here on the edge, you can see gen, off, and line. Now, down in the description below, I'll post a link to this box from the manufacturer and basically how it's wired and how it works. And the way they operate their box is they leave all these switches in line. Line is power coming from the utility, and then you have an off setting, and then you have a gen setting. So normally on the gen setting, there would be a plug instead of this knockout box right here, where you would actually be able to plug your generators in. But as you guys can see in my other videos, my generator plug is actually in the garage, and if you watch those videos, you'll understand why. So the difference between my setup and how they're going to explain it in the video is they leave theirs in line all the time for utility power, and then in the event of an outage, you're supposed to plug your generator into the plug that would be here, and then once the generator gets stabilized, you switch all these plugs into the gen setting, and then that would allow you to basically repower your house off of your generator. What I've done here is instead of tying my generators into the gen setting is actually the output of my inverter. So to get an uninterrupted transfer over to batteries, I run my switches in gen mode, which is actually my generator, all the time. And then in the event that I need to do maintenance on the my inverter system, I can just switch these all back to line, and you can flick these switches fast enough that you won't interrupt anything in your house. If your TVs are on, they'll stay on. If the fridge is running, it'll stay running. All that kind of stuff. You just flick them down really quick. And then there's also an off setting just in case you need to do some kind of maintenance on the power panel and the inverter system all at once. So then the output from these switches then runs through this tube basically into this junction box, which is just where I have the output coming from the ProTran switch box and the circuits coming from my power panel. So what you do with this ProTran box is you disconnect the output from a breaker and you run a cable from this breaker down into my junction box into one of these switches. Then you run the output from this switch down into this junction box and then to the circuit that this breaker was powering. So if this breaker once you disconnect it, you'll have a dangling wire that's providing power to something in your house. That wire then needs to be connected into this box. So this box has basically an input coming from my inverter, an input coming from my utility, and then an output going back into the circuit that's in the house. Now, if you watch the video, they do an extremely good job of explaining exactly how this works. And it took me tons of research to kind of find this thing on the internet. And then, I was able to find it on Craigslist. I think I wound up getting it for about $100. And I literally could not ask anything more of it. The only regret that I have is that I would have got one that can support more switches. That's literally the only regret that I have. So basically, that's the way this works. Is I have this 30 amp breaker, powers the inverter in the garage. Then the inverter returns voltage back into this system and powers these individual switches when it's in gen mode. And then this will actually return power back into here. So I've identified the circuits on my power panel that I wanted to interrupt. So I pretty much have anything that has lighting on it, my garage door opener, microwave, refrigerator, and a dinette, a couple other things throughout the house. Really the only things that I don't have powered in the house are anything that's 220 volts. So the system really just kind of works flawlessly. When the power goes out, you don't even notice it. All the TVs stay on, all the computers stay on. As long as it's not a large-scaled outage. Usually I have internet service still in my house, which at that point I can tether off my phone, so that's not even a huge problem. And the system just works unbelievably. We had a power outage in my neighborhood several months ago, and I didn't even know it. And I was driving down the street, I was coming into my place, and there were people just standing in their driveways because they didn't have keys to their houses, because they just always went through their garage door. And I came around the corner, hit my garage door opener button, the garage door opened, I walked in the house, carried my groceries in, I put them in the refrigerator, and I was in my house for probably a solid 20 or 30 minutes before I actually realized the power was out. And the only way that I actually realized the power was out was because I went to go turn on the stove, and since my stove is 220 volts, it wouldn't turn on. And then I was like, oh man, power's out. And, I started going around my house just kind of verifying what was getting power and what wasn't getting power. And I was just, really impressed in the system. And then, once utility power was returned, everything just came back on, and I didn't even, realize that, the power had switched back over to utility. So, I mean, the setup is really great. I recommend this for anybody who's just really trying to protect their family in the event of an outage, or you might have grandiose schemes for a prepper type situation or something like that. But, the system, I'm really happy with it right now. And kind of the only thing that I want to go from here is adding solar into the system, which it's winter currently where I am right now, so I'll probably wait till spring or winter time to kind of take on that part of the setup, and I'll probably start a new series of videos on that. But feel free to post in the comments. I try to be as responsive as possible to answer any questions that anybody has out there, but this is the actual utility part of the system and how everything is tied in here. One thing that I do have is I have these instructions here, just kind of on emergency shutdown, what to do in a power outage, and what should the system look like in normal operation. And that's just in case, you know, my significant other is here and needs to do something. But like I said, the system is made to be completely unattended. So in the event of an outage, you shouldn't have to come in here and flick a switch or a breaker. Everything in the house is going to just stay on, and you're not even going to notice it unless you're using the dryer, the stove, or the air conditioning. I even have the heat powered because I have gas heat, so I just really need to run the blower. So that even runs the system itself. I've got tons of protection in the system. You really can't pull more than, the inverter can't pull more than 15 amps. I have a circuit breaker in between this panel and the inverter in the garage, so you can't pull more than 15 amps, and then you can't pull more than 30 amps here out of this box, and then each one of these individual circuits have 15 or 20 amp breakers on it. So really, in a worst case scenario, the most you could ever pull is about 20 amps coming out of the system, which my house will never do. I run on average probably in the 800 watt range. When I'm at full tilt, I might be at 12 to 1500 watts. My house is pretty energy efficient. I have LED bulbs everywhere. I even have LED shop lights in my garage. And all my TVs are LED, very low wattage, nothing to really be concerned about. My big power draws are the garage door opener and the refrigerator, really. Outside of that, I mean, my garage door opener even pulls more watts than my furnace. So I really am not too concerned about overdrawing or doing anything like that. I do have tons of monitoring on my system. I do use a product called Nereo, which is an app that you can get for your phone. And I will also link that in the description below. And it is a system that you can clamp onto the main feed lines coming into your house, and it essentially allows you to monitor your circuits and big utility items in your house. So you can make the system aware of stoves, refrigerators, microwaves, air conditioning, heat, and it'll actually track all that data and tell you how much power you're using over time. I think that's an essential part of this entire system, is basically understanding what your power draw looks like and what it looks like at peak, what it looked like at rest, and what I consider your running watts, which is just wattage that are running all the time when you're not at home and nothing's going on. Like I said, my house is a smart house. I have, you know, Nest thermostats. I have pretty much everything, Wemo light switches, LED light bulbs, everything that allow you to control your house remotely, but is also extremely energy efficient, which is why I say my system it doesn't draw a lot of watts. I mean, at full tilt with the air conditioning running, the microwave on, the stove on, my TV's on in my living room, the lights on, everything, the garage door running, I'm probably at that point, I would be pulling somewhere in, I would say, the 4,000 watt range, and that's not even realistic because I would never run all that stuff at the same time. It'd be very rare that any of that stuff would happen, and I definitely wouldn't be doing it in the event of a power outage situation where I'm trying to sustain the batteries as long as possible. If you look at the video that I'll post from the manufacturer's website on this, you'll see kind of the differences and how they'll actually have their generator plug here. This generator plug is too far away from my system for it to work, and just because I'm doing things differently, instead of using it for a generator, I'm using it for the inverter. If you look at my other videos, you'll kind of understand what's going on there and get a better understanding of why exactly I'm doing that, and it should make sense. I'll try to make a diagram to explain the entire power flow of the system, but I'm hoping this will kind of clarify some things. And If you guys have any questions, I try to be as responsive as possible, because I believe in, the sharing of information. Remember, do all this stuff at your own risk. Messing with electricity is extremely dangerous, but if you ever have any questions or concerns, just feel free to reach out to me and I'll do my best to help you. Again, thanks for watching. I'll start a new video set once I start tying in the solar system, and we'll kind of go from there. Again, thanks for watching. I really appreciate it. And if you like this video, please give it a thumbs up. Thank you.